Hi there, PlatformCon. My name is Nick Eberts. I'm a product manager on the GKE team. And today I'm here to talk to you about how to build a platform on top of Kubernetes and why you might want to remove the personality of those clusters in the process, right? And we're going to talk about techniques like GitOps, both push or pull. But before we get into the how, let's talk about maybe why you might want to do this, right? So the first consideration might be probably one of the more obvious ones, but let's say you're asked to deploy an app and you're supporting it in one region. But you know that like in the future, if this is successful, it's going to expand to another region. So what do I need to do to design my infrastructure and all of the configuration ahead of time to get ahead of this need, right? Another thing might be in a previous role, you've recognized that managed Kubernetes offerings like GKE often have immutable configurations and settings that, so like when a new feature comes out, you can't just upgrade that cluster. You actually have to deploy a new cluster to take advantage of that new feature, right? And so how do you avoid putting yourself in a situation where that is a really arduous task, spinning up a new cluster, putting work on that cluster, turning down the old cluster? Well, it's fairly simple, right? I mean, the idea here is that you're automating the install and adding of a cluster to a fleet of clusters. Um, and if you do this right, then it should be as simple as just deploying a cluster with the right label. All the magic happens, and then that cluster is now, completing work in your fleet as though it's always been there to begin with, right? But so what do you need to do, right? Like what are the layers and what are the things that you have to define and automate to make a system like this work? Well, this is how I look at it. There's sort of a layer cake of things that you have to handle to build this platform that I'm talking about. And on the bottom, you have core infrastructure, right? So you've got VPCs, IAM, storage, all the things that you need to be able to support your applications and the security of those applications on a cloud provider or even on-prem. And then this also includes the actual Kubernetes clusters, right? That's infrastructure. It's typically VMs, unless you're using GKE Autopilot, but still, it's infrastructure nonetheless. So you've got this core infrastructure layer, and then on top of that, you've got fleet application cluster configurations, right? So these are the configurations of all of the clusters that are serving application workloads that are kind of the same within the same security boundaries. So, things like making sure security tools are laid down, making sure your Kubernetes role-based access controls and policies and quotas are laid down, making sure that you've got your security runtime security tool installed, right? All these things can be sort of laid out in configuration and prepped so that you can just add a cluster and it sort of takes advantage of that, right? Then on top of it, you've got this concept of having teams. And then within those teams, you probably have a multitude of services. So a team could be one service or it could be many services depending on your org chart and how you ship applications. But I like to consider here that a service is basically a namespace and a team is an aggregate of namespaces. And the team is sort of the strong RBAC boundary between an aggregate of namespaces across a fleet of clusters. So the abstraction here is that I'm defining a team and the services within that team and the boundaries, and then it's completely abstract from the actual cluster, right? But it's related to all of the clusters in the fleet. And then, of course, you have this cross-cutting layer for central tooling that we all seem to always have, right? There's always something that needs to run centrally to work over your entire fleet, but doesn't necessarily belong on top of the clusters that are running your workloads. So, yeah, so we have these layers, we understand them, but we need to set some boundaries. The joke here is, do you get it, right? Get is actually a great boundary. So what you could do is, as you're laying out this system, start to think about each persona, infra engineer, platform engineer, the actual users, whether they're developers or ML folks, or they're just shipping COTS applications. You think about these personas, and then they actually end up mapping to Git repos mostly, right? And so your infrastructure as code is going to be in a set of Git repos, maybe not all in one, so that when you add a cluster, you're just adding that code that says, hey, add this extra cluster in this region, right, with these labels. And then you have some CD tool that's kicking off the deployment of that infrastructure, right? And the same thing kind of applies for application cluster configs. Oh, I need to make a change across my fleet of clusters. Maybe I want to do it in waves, so I have different labels. But the idea here is that I'm making a change to Git, and that change is actually being synced into all of the clusters or pushed to the clusters with a CD push. Either one can work, pull or push. And then, of course, your application teams, right? They're going to have a number of Git repos, whether it's one per service or one per team, or I don't know, maybe you're doing a mono repo and you've got all that sorted out. But the point is that you've got these Git boundaries. And one of the things I like to call out here is that by having these boundaries and making them all at least read-only org-wide, you're sort of promoting inner source. So let's say I'm a platform user and there's a new pattern, a new golden path, right, that I'd like to implement that doesn't exist yet. I could put in an issue or a feature request to the platform team on the product of the platform, and maybe they're backlogged, maybe they have other things that are more important. So on top of that, I can try or write the code myself. I can make that pattern and then I can PR it, right? And the platform engineering team can then, of course, have the power over whether or not that gets merged, because the boundaries of Git are allowing for me to contribute, but also giving the control to the teams that need it. So it's super important, I think, to establish that sort of culture within your org. All right, so we've talked a little bit about like the abstractions. So let's talk more about how this would kind of lay out, right? So the first thing that we're talking about doing is managing your fleet. And when you're talking about managing a fleet of Kubernetes clusters, you'll probably come to the conclusion that you need to have some sort of meta control plane, right? Cloud providers, I know for sure GCP, we have a managed fleet control plane, right? So we're providing that to you as a service, but you could also build one on your own. And I'm sure other distributions and providers will start to catch on to that over time. But the point is that you need a control plane to manage all of those clusters, right? So that you can slice and dice them, ensure that certain configuration lands in certain clusters, put certain features on certain clusters. It becomes important. And then the second key component here is that there's a number of, or a config repo that holds the configuration, the Kubernetes resources that need to be deployed across your fleet of clusters. And you're either syncing that information throughout your fleet, or there's a CD push upon change in the repo. But the idea here is that the desired state of your fleet is in a Git repo. And so when you add a cluster with the right label, and in this case, I'm showing wave 1, but maybe it's wave 1 production or something, right? Because you have a production fleet. But the point is, when I add this cluster with the right label, it triggers a bunch of actuation against that repo. So that repo is that agent or the mechanism that I have that's deploying it into the clusters has some ability to recognize labels and then filter out certain configuration based on those labels, right? If you're using Argo CD, that's going to be in using labels in the Argo CD secrets. If you're using config sync, which is Google's tool, that's going to be in using we have a cluster repo and label selectors. And like both of these things just give you the ability to decide which configuration goes where. All right, so what are some other concerns that are necessary with a fleet? Well, if you're trying to make a fleet of clusters that basically kind of feels and looks like one giant multi-regional cluster or multi-cluster cluster, right? Just one cluster, but we're in reality, it's multiple clusters. The first thing that you need is flat networking, right? And if you're doing multi-region scenarios, you need that flat networking across regions. Now, one of the advantages with Google Cloud VPCs is that they're global, right? So that's easy for us. Our GKE container network interface allows so that pod in region 1 comes up, it can route to pod in region 2 without having to go through a load balancer. And then so the next concern that you have to have is service discovery. So how how within Kubernetes in cluster one am I going to be, is pod A going to become aware of another pod that might not be on that same cluster? There's several projects out there, multi-cluster services, which is open source up in Kubernetes. We have an implementation on GKE that allows you to discover pods in other clusters, or you could use a service mesh to get that cross-cluster discovery. But I think that's kind of a requirement, especially if you want to be able to fail over inter-cluster chained calls where front end calls back end locally, it's not there, and it can go to another cluster or another region on retry. And then the last part of networking that's super important is the load balancers, like the entry point to your cluster. You want that to be probably one IP, right? But the back ends may be spread across multiple clusters. And so that whenever the endpoints of the back end to your load balancer change, they automatically get changed in the load balancer. And then you could use fancy routing techniques to say, hey, serve this traffic to the least latent location for my end user. Or I'd like to use waits or cookies, all that layer 7 sort of fancy routing stuff. You would like to have that sort of at the edge of your cluster and across multiple clusters, right? This allows you to sort of onboard another cluster. And when you onboard that other cluster, the configuration that, again, actuates, it pulls in all the things that it needs to pull in, installs all the tools. And then eventually the applications start to come up. And when those applications, those pods that are running your applications become ready, then they just become part of endpoints that can be reached east-west between clusters, or they become endpoints if they're a front end and externally facing to the cluster application, they become endpoints in a load balancer that already exists. So like in this scenario, let's say I'm on the East Coast and right here, and I'm hitting this web service as a user, right? And then you pull up the second cluster. Once it becomes ready, and if you've got your route set to close, least latent, I'm going to get routed to the cluster that's closest to me, and poof, immediately I'm getting better performance because of the speed of light, right? So I'm going to hit that cluster in US East. I live in Atlanta. That's much closer for me than going to central US. Okay. So I know that's a mouthful. I just want to, quickly kind of go over this topic and this idea of immutable clusters, or not immutable clusters, but fungible clusters without a personality. And I'd like to say, can you dig it? And I feel like, yes, you can. So if you have any questions or you'd like to follow up with me or any of my teammates about how we think about these things, please reach out to me. My Twitter and LinkedIn and Blue Sky handles are Nicholas Eberts. And I hope you have a great PlatformCon, and I'm looking forward to checking out all this stuff. All right. Thanks, y'all. Take it easy.